Appendix A, Emergent QCD from PK black hole geometry. A point 1, domain flux structure, and the SU3 gluon spectrum. In the superblock universe, each quark flavor corresponds to one of the 6 co-located spacetime domains DI-DI. Quarks are not fundamental point objects. Rather, they are continually regenerated excitations of color flux, trapped in the ergosphere of an extremal Planck curve, PK, black hole. Color interactions arise because a PK hole can draw electromagnetic flux from any of the 6 domains, twist it via frame dragging, and re-emit it into any other domain. The fundamental objects mediating strong interactions are therefore cross-domain flux transfers, phi j, dj, di, ffij, dj, die. The projected color charges, RGB, of the prime domain are linear combinations of domain fluxes determined by the octonionic 8-phase structure. The gluons of SU3 arise as traceless combinations of these transfer operators, Gij, Fij, 3, 1, Dij, K 1, 3F, K. This reproduces exactly the 8 gluons of the standard model, including the off-diagonal, color-changing, and diagonal, color-retaining states. The octonionic phase mapping determines which domain pairs correspond to the Gell-Mann basis. Thus, SU3 color symmetry is emergent from the geometry of PK-driven interdomain flux. A point 2 linear confinement as a necessity of PK frame dragging. A quark corresponds to a color flux tube, whose near-horizon anchor point is rigidly tied to the rotating PK hole. If 2 quarks attempt to separate, the shared flux tube must stretch. In an extremal Kerr geometry, frame dragging induces a fixed tension in any such tube. Sigma equals hc to the power of 4 pi r erg squared. Sigma equals 4 pi r erg squared h bar c. For an extremal PK hole with r erg equals 2 LPL r erg equals 2 LPL, this yields sigma approximately equals open parenthesis 425 mega-electron volts close parenthesis squared, sigma approximately equals open parenthesis 425 mega-electron volts close parenthesis squared, which is the empirical QCD string tension. The confinement potential V of R equals sigma R V of R equals sigma R arises with no free parameters, mandated purely by the geometry of the PK seed. Quark confinement thus follows inevitably from near-horizon Weyl curvature. A point 3, non-abelian gluon self-interaction from multidomain flux. Since gluons are flux transfer operators Fij, Fije, interacting gluons correspond to interacting domain transfer channels. Because Weyl curvature is nonlinear, any flux transfer modifies the ergospheric geometry and therefore modifies all other transfer channels. The commutation relations of these operators are Fij, Fkl, Dj, Kfil, date, IL, Fkj. This is isomorphic to the SU3 Lie algebra. Ta, Tb, if ABC, Tc, Ta, Tb equals if A, B, C, Tc. Thus, non-abelian gluon self-interaction is not an assumption, but a derived geometric property of the PK hole-mediated multi-domain flux network. Conclusion of Appendix A. All essential features of QCD, the 8 gluon states, linear confinement, and gluon self-interaction, emerge naturally from 6-domain flux geometry, extremal PK frame dragging, octonionic 8-phase structure, and the nonlinear curvature of conformal twistor gravity. No fundamental SU3 gauge fields are required. Strong interactions are an emergent phenomenon of PK hole dynamics in the 6-domain supersphere.